Okay, amazing students. Today we're looking at some FRQs. This one, how's that sound, is number 8. I don't know what that means for you, but that's what number it is for us in our curriculum. So we're told that we have this table goes from 0 to 6. Okay? The graph consists of line segments connecting the points below in the table. Okay, so these 6 points here, or rather these 5 points are on your graph. Okay, so that's what we're going to start with here for part A. It says, suppose this is true. Sketch the graph for the entire grid, right? This says from -6 to 6, which means from the entire left side of our graph to the entire right side of our graph. But here's the problem. We're only told about the right side of our graph. So we have to ask ourselves, how do we plot the left side? Right? It says from -6 to 6. We have from 0 to 6 done because they gave us that part. So what's going on to the left side? Well, this little bit here kind of tells us what's going on. So this is some fancy notation, and hopefully you recognize this as the notation for f is an even function. An even function. This is our definition of even, that f of -x is the same as f of x. Okay? And because it is an even function, every point that we're going to have, so every x comma y value on your graph, and that's what all these are, right? These are x comma y values. Every xy has a friend called -xy. Okay? This is a numerical explanation that every xy has a -x comma y, which means our graph is also y-axis symmetrical. Okay? It has symmetry across the y-axis. So everything on the right side of our graph, all of these points are going to end up over here on the left side of our graph. That's what it means to be y-axis symmetrical. So we can go ahead and plot all those because we know that's where they're going to end up. And that would constitute your answer. Okay, now the scoring. You would be awarded 1 point for getting the graph right, the left side and the right side. You would be given 1 point for stating that it is an even function. And you'll be given 1 point for the numerical reason. So this one question here is worth 3 points on the FRQ grading scale. So now let's look at part B. Part B says sketch a graph of this. Okay, now this is a transformation because we're talking about doing something to the graph of f, right? This up here that we just got done, that was our graph that we're calling f. Okay, and what 2 things are we going to do to our graph of f? Well, first we have a negative out here. So that means we're going to have a reflection across the x-axis. Okay, it says make all the y values negative. So everything on the top of your graph is going to be translated or reflected down to the bottom half of your graph. Remember, f of x is your y values. Okay, so it says make the y values negative. These are y values, making them negative. Positive y values are above the x-axis. Negative y values are below the x-axis. So first it says reflect across the x-axis, and then we have to translate each point 2 units up. Okay, so we're going to take these 5. This looks like a little valley, right? A little valley here. We're going to take this valley or this canyon, and we're going to flip it so that it's going to end up looking like a mountain. Sorry about that. I just did a lot of work without recording. So we're to here. Let's see. What did I talk about? I talked about the actual graph, right, being reflected across the x-axis, and then move 2 years up. So then I talked about the rule. Okay, we have this rule that's one point. The graph that's 1 point, and your transformation explanation is 1 point. Okay, so whenever we're doing a numerical explanation, right, explain how the new coordinates got made up, you have to have this rule in there for the coordinates. Okay, now on part C, okay, we have this notation, which means we have an odd function. Okay, this is the algebraic definition for an odd function. Negative x here, negative on the outside. Okay, which means it has origin symmetry. So every point goes to here. Now I think we got caught up to where I was. So let's look at the original 5 points from your graph. So each one is going to be changed, right, in this different way so that we have some even or some odd function symmetry. So this point at 1, 2 is going to become -1, -2, right? You switch both of the x and the y coordinates. Okay, and then this point at 2, 2 is now -2, -2. And this point at 4, 5 is now -4, -5. So we're down here. And this point at 6, 5 is now at -6, -5. So here we have the graph that has been an odd function with origin or rotational symmetry. Okay, so you'd get 1 point for stating that it's an odd function. You'd get 1 point for the graph being correct, and you get 1 point for that numerical explanation for your reasoning. Okay, because it is an odd function. For every point we have on the graph, there is a corresponding point where the values are the opposite signs. Negative of the x value and the opposite of the y value. Okay, so that was a lot of transformations and even and odd function symmetry. So let's look at number 9, FRQ number 9. So in number 9, we have a graph. Okay, the graph represents F, and then this table represents G. Okay, table of G, whose graph is formed once again by connecting all the points in the table with straight line segments. Okay, so this is a continuous graph that have these points on them. Okay, so first of all, we want to find some value, right? So this is just plugging and chugging. Okay, so we first need to identify what is F at -5. So you come to your F graph when x is -5, and we come down to the y value of, looks like -4. So the y value from the F graph when x is -5 is -4. Okay, we're going to do the same thing here for our composition, right? This is a composition. So first we're going to go to f of 2. So when x is 2 in your F graph, this has a y value of 0. Okay, so we are really looking for G at 0. So we come over here to the G table. When x is 0, we find a G value of -3. All right, so this is -3. Now let's put everything else back in here. We have a -2 times, right? There's multiplication, and then we have subtraction between those two values. Okay, so our, please excuse my dear Aunt Sally, right? Your PEMDAS order of operation stuff says we do multiplication first. So this is a multiplication. It's got the dot. So we always do multiplication of our values first. So -2 times -4 is +8. And then we have minus -3, which minus a minus is a plus. And our final answer is 11. So how does the grading work for this? Well, you'll get 1 point for evaluating your two functional notation things. So 1 point for getting both of those. And then you get 1 point for getting 11 as your answer. So this is a 2-point problem. Okay, part B says is G even, odd, or neither? So we're looking at G now. Is it even, odd, or neither? Okay, so the x's, of course, change signs. So do the x's, well, what are the y's doing? That's really the question. Are the x's changing and the y's staying the same, right? If so, that's even. Are the x's changing and the y's changing? If so, that's odd. And if something else is happening altogether, then that's neither. Okay, so let's look at the y values. Here we have a -2 for a -4. Here we have, that's a +2 for our -4. And here we have a +2 for our +4. Okay, a -1 for -2 and a -1 for +2. So I am of the impression that this is what's going on. Right? For every point on our graph, there is another point where it's a negative x value and a positive y value. So the y values aren't changing. So I'm going to go ahead and say that g of x is an even function. Okay, so there's 1 point for saying that it's even. You get a point for saying that correctly. And now the other point is a numerical reason. So remember, we're looking numerical. So we have for every x comma y, for every point there is on the graph, there is also a point where the x value is negative and the y value is the same. Okay, so that's your numerical reason. Okay, for every point that we have, there is a corresponding point where the y value is the same and the x value is negative. Okay, that's your numerical definition of an even function. Okay, the algebra. Oh, yes, the algebra. Okay, so this one is a pretty special problem. We know that the x value is -2. Okay, so the first thing we're going to do is we're going to simplify this equation. We have to figure out what is our equation when x is -2. So we replace x with -2 and we simplify as much as we can. Okay, so this is 4a plus 6 plus 10. Our equation comes out to be 4a plus 16. Okay, so that's the equation that we get with an x value, or an x of -2. So we have an equation for p of -2. Super. Now we have to figure out what is the number that goes along with p of -2. So we're going to apply this composition. Okay, we're going to compose this function. First of all, we go to g at -2. What is the y value from the g table when x is -2? When x is -2, the g value is -1. So first of all, I replace this with -1. Now I go to my graph, right? So now I have a graph. On my graph, with an x value of -1, when the x is -1, our y value is +2. So I know that p of -2 is equal to +2. So now that I have an equation for p of -2 and I have a number for p of -2, I can set these things equal and solve. Okay, so the p value, or the numerical value, has to equal the equation. Right? The numerical value when x is -2 equals the equation when x is -2. Okay, and we solve this, of course. We minus 16 from both sides, minus 16. And we get -14 equals 4a. Divide both sides by 4. And they like to leave it as a fraction. But if you write it as -3.5, nobody's going to get upset with you. So there is 1 point. You get 1 point for doing both of these things, for finding the equation and for finding the value. And then you get 1 point for answering the question. Right? Setting these things equal and answering the question is another 1 point. So that was 2 points too. 2 points also. Now let's look at D. Identify the intervals along the x-axis where f of x is less than 0. Okay, first of all, what does this mean if f of x is less than 0? Well, that means that the graph of f of x is going to be below what? Well, below the x-axis. Okay? Because all y values are negative, or all y values are less than 0 below the x-axis. So write the words below the x-axis. That is the reason that we're going to be able to write that. So now let's go up to our thing and look, where is the graph below the x-axis? Okay, so all of these points right here, this is the point where the graph is below the x-axis. So we start at -5, and because it's a closed dot, okay, we can use a bracket here. Because there's a closed circle at -5, we can use a bracket, but we have to have an open parenthesis there at 3.5. So there is one interval where the graph is below the x-axis. Now there's another interval over here. So we have another parenthesis, and we go until +5. Okay, all of this stuff is where the graph is below the x-axis. Now, because there is an open circle at the end, we're going to have a parenthesis for +5. Okay, so if there's a closed dot, we can have a bracket, -6 to 3.5, -6 to -3.5, parenthesis. Then we have it again from 2 to 5. Oh, good point. It doesn't go to -6, it only goes to -5. So -6 should not be part of your answer, since -6 is not even on the graph. -5, well spotted, my dear student, well spotted. Okay, so there are a couple of FRQs for you. Hopefully you have learned some things about how we grade them, right? The rubrics that go along with them, and how many points each of them are going to be worth. Okay? Have a good evening. We'll see you in class next time.